Welcome, everybody. My name is Michelle Gutzeit, and I'm the moderator of this session. This session is recorded, and the video will be available in a week. Today, we have the great Adam Auerbach to discuss the engineering excellence in a VUCA world. Adam is a head of cloud agility and testing practice. We have, you feel free to add any question or comment to the session. I will be moderating them. And at the end of the session, Adam is going to answer all your questions. So back to you, Adam. Thank you.
Awesome, thank you. And welcome everybody. So as I was introduced, my name is Adam Auerbach. I am the head of cloud agility and the testing practice at EPAM. So that includes our engineering excellence practice, our agile practice, as well as the testing practice. I've been with EPAM for 4 years now, and I have a lot of experience in transformation and helping companies improve their performance. So please, you can find me on LinkedIn. Please connect with me if you have questions. If you you're going through transformation with your company and you need some help, feel free to reach out. I'm always happy to answer questions. You can also follow me at Twitter at Bugman31. So let's go. So VUCA is a very common term, especially these days with the pandemic and what has happened. So if you're not familiar with VUCA, it stands for volatility, uncertainty, complexity, and ambiguity. It's actually a term that the military came up with many decades ago and how they adjust strategically. In the last, pre-pandemic, VUCA was really associated with digital disruptors. So companies like Uber or Amazon or PayPal, who were reinventing industries based off technology and their ability to quickly iterate and change in order to meet the evolving client demands. But now with the pandemic, we've all been thrown into this VUCA environment where every day is different, right? 2 years ago, we were all sent home. Some companies were prepared for that, some were not. How did that impact our working environments, being able to move to virtual meetings, being able to collaborate online? So this really has changed our world. And in the last 2 years, it hasn't just like, we didn't just go away and then come back and everything's fine. We're still in this world of we don't know. There's now a new variant. Things are still evolving. Can we go to the office? Do we not? Are we ever going to go to the office? Can I now work from wherever in the world and I don't have to be, close to my team as before? And a company's success is really driven by their ability to manage in this environment. And that's what you're seeing in this last year and a half. You're seeing companies really understand that they are or are not prepared for this type of VUCA environment, and now they need to evolve. And so what does that mean? It means that they have to have a better vision. They have to understand all of those factors. They need to be able to execute and iterate on that vision, and they need to be able to do this very quickly, and they need to be able to pivot very fast. I think sometimes we get into this sense where we need to have a really clear understanding of how something works or the problem we're trying to solve before we invest our engineering talent. And then as we do that, we're really trying to get everything right before we put it into the client's hands. And that doesn't work in this type of setting. If you look at Tesla, for example, Tesla puts out a new car and it's somewhat half-baked. Right? There's a platform, there's the car is run through technology, but all the features aren't there and all the features aren't fully robust. But what they're able to do because of the software, because of their development process, because of how they are able to give updates, that the car is iterating. when you first got a Model 3, you had one type of backup camera. And then after a couple months, the backup camera now has the video from the mirrors. The self-driving aspect continues to evolve as it's learning, right? And this is Tesla understanding how people are using their products and understanding how things are evolving in the world, and then how to make the car adapt to those changes without having to wait for a whole new car coming to the market. And that's changing, revolutionizing really the automotive industry. And they're eating, Toyota, Ford, GM, they're eating their lunch, right? I mean, Tesla is now the biggest car company in the world because of this ability to have a vision, to be able to deliver with speed, and then the flexibility of iterating. And that's what we need to be able to see within our engineering teams. We need to be able to get features to our clients early and often. We need to understand how they're using those features. We need to be able to pivot from a business perspective, if we're not getting the right behaviors that we're expecting with our clients. And so this really has a strong tie back to our teams, our engineering culture, and how we're working. And this is going to be the new normal. This, I must have, last year people would say, well, when are we going to start to travel again? Oh, I think it should be at the end of the year. Maybe it's going to be at the beginning of this year. I thought, earlier this year that we would get to travel. That's not happening. And so now with this new variant, and who knows how long this is going to be, but this is the environment that we're in. And so what's happening is we're getting exposed in some extent that our processes and our skills on our teams are not good enough. And we need to be able to improve speed. We need to break down our impediments. We need to understand better of how we're working. And we need to be able to invest in our people to get them the skills that they need to take advantage of the right technology stack in order to be able to deliver quickly. And this ability to learn, to evolve your processes, to work in this new normal, this is going to be directly tied to the company's success. Many companies, financial services, insurance companies, they're starting to pivot, and they're saying, we're a technology company first. And that pivot, that recognition that we are driven by IT versus we're driven by the business, that's going to enable them to really shake up their industries. And it's already underway. So from a software development perspective, VUCA really matters because it really changes how we're working. It's not good enough to be a smart engineering team, but we need to be able to have research and development. We need to be able to learn. There's new technology, AWS reInvent just happened. There's new technologies coming out from the cloud. How do those technologies impact our applications architecture? Do you know that? Do you know how to take advantage of serverless or containers? And as they're adding new features, are you given time to be able to learn those new capabilities? We need to have visibility. We need to have visibility into the way the team is performing so that we can knock down impediments and improve our performance. We also need to have visibility into how the client and end user is using our products, because that's going to give us insights into how to make better features, how to deliver better customer value. We need to have a modular approach. It's been talked about for many years, right? A big monolithic application takes an army to deliver. Well, that's flexible, that's not going to have speed. And in order to get speed and real flexibility, everything has to be modular. We have to have microservices. Everything has to be loosely coupled. How we write our methods and classes has to be very, very modular so that we have the ability to move things independently into production without having to manage those dependencies. Otherwise, that creates constraints, that slows us down, and we're not going to be very flexible very fast. The small iterations really help us learn on the fly. And that's what's critical, being able to put something out there, see how it's respond, and then iterate from there. When Facebook releases a feature, a certain population will get that feature. They'll be able to have the metrics in place to understand if that's successful or not. And then either they can roll it out to a greater audience or they're able to kill it. And that canary releases, blue-green deployments, all of that is a key capability. And all of this is part of engineering excellence. And that's what I'm gonna talk about more about, is what exactly is engineering excellence, and so why is it so important within this VUCA environment? So let's dive into that a little bit more. So maybe 10 years ago, maybe 15 years ago, Agile was the big buzzword, and obviously there's still many teams that are still trying to be Agile today. But when Agile first came out, we thought that Agile was the solution. We thought Agile by itself would get us into speed and flexibility. But what happened is this: we took Agile, we put people into teams, we gave people new titles like Scrum Master and Product Owner. But because the way the teams worked didn't change, because they didn't evolve how they got stuff done, you would get multiple sprints of development, maybe some testing, but you would still require some level of hardening, some set of activities to make sure the code could move to production without issues. And this isn't Agile. This is still waterfall. And so this really highlighted the fact that we need to look above just like the team construct, but look into the other ways that the team is working, as well as maybe some of the other factors around the team, to understand how we could get to a place where every sprint we're able to deploy something to production, or maybe even every day or multiple times a day. So Agile was the first step, but clearly it isn't enough. So then we moved to DevOps, and DevOps really, I prefer to think about DevOps as a philosophy of delivering high quality software faster. And now we're getting closer to being able to understand how to be a high performer in a VUCA environment. And when we look at teams and we say, okay, well, we have an Agile team, but what can that Agile team do by themselves? And what DevOps has talked to us about is that Agile team needs to be able to own it. They need to be able to be in control of development, testing, and getting their features all the way deployed into production. They need to have accountability for the quality and the environments, and maybe even some level of the production support. And so DevOps really, if we're doing DevOps correctly, we're not just talking about a run organization, or we're not just talking about CI/CD, but we're talking about how do we enable teams to do everything on their own, but safely, right? We're not just saying, hey, here's all of the keys to Azure, go create your own environments and good luck with that. No, we're asking our shared service teams to create playbooks or containers, templates, developer portals, automation frameworks. We're asking our shared service teams to create capabilities and provide support when the Agile teams need help. But the Agile teams are now able to take advantage of those best practices, so that way they can own their features all the way through to production, but they can do it very safely. So this now gets our Agile teams more accountable. It gets them working much faster, but there's still more to this picture. And that's really where engineering excellence comes into play. And at EPAM, we call this EngX for short. But basically, there are, I got two number sevens. There are 8 core principles of engineering excellence, and I'm going to go through these in a little bit more in detail. Obviously, shit in, shit out, as we say in America. So it starts with writing clean code, and I'll talk a little bit more about that. The cloud is a key capability of engineering excellence that allows us to have that modular approach. Now, it doesn't matter if it's public cloud or private cloud, but being able to have containers and take advantage of serverless capabilities, that is a key component to being able to move very quickly. The tooling matters. So having an integrated tool set that allows that continuous flow is critical. Being able to have visibility into the performance of the team or the set of teams and then into production, that's going to allow us to understand where we can improve. Quality gates are critical. We need to be able to have testing baked into this process. Testing should not be a separate team. It should not be a separate function. It should be embedded into the Agile teams. And we should have gates that are baked in so that code cannot move past an environment without meeting certain requirements. Security and compliance and performance has to be part of this process as well. Obviously, as you move to the cloud, there's greater concerns about denial of service, attacks, and other types of security risks. So we need to make sure that security and performance are all baked into this process. Continuous delivery, so everything's to that CI pipeline, and it really operates as an automated factory as we move code through our different environments into production. And then being able to manage that infrastructure, that cloud environment as code so that it has its own pipelines, its own security and testing checks before the teams are using it. So all of this is how we ensure that our teams are high-performing teams, being able to deliver fast and flexible in this VUCA environment. So let's go into a little bit more depth about each one of these. So the first one is clean code. And at EPAM, this is something that's really near and dear to our heart. And I don't think enough organizations spend time with their developers to help them understand what does this mean. At the end of the day, how we architect our solution, how we write our methods and classes, how we instantiate our API, all of this is so important, because if it's done poorly, if it's done without documentation, if it's done in a way that doesn't allow us to be testable, all of this is going to create constraints later on in the process, and the team is going to experience drag because of the code not being written in a way that people can understand it, or that it's you have poor reuse, or maybe just some of the functions are just written very long. And so it's really important that the developers understand what it means to write clean code, and that we take advantage of like the code scanning tools and code smells to really make sure that we're analyzing what we're written, and we're holding our developers to a high standard of what they're building. The next is more of an Agile principle, which I mentioned in my Tesla example, is we need to be focused on MVP. We need to get something, and I think the last speaker kind of mentioned this a little bit, which is we need to be able to get stuff out the door quickly and early and often. We need to be able to iterate. And by doing that, we're going to get feedback from our clients. We're going to get an understanding of, hey, are we meeting their needs? What else are they missing? Maybe in this case, maybe a skateboard is good enough, and we can stop and then invest in other areas. We need a car. By spending all of our time building a car, maybe things change, right? Apple is trying to build a car today. Who knows how many iterations of that car they've gone through? Maybe they started building a car that looks like a traditional car that has like CarPlay in it. But now, as Tesla has really pushed the envelope towards autonomous driving, now their car really needs to be something different. And you see that Apple has spent years and years building this, and we hear about it, but no one sees anything. And that's the issue. Now, if Apple was to come out with something earlier, they would start to be able to play more in this market, get real tactical feedback, and really be focused on what they're building. It's really important that we don't think of minimal viable product as, well, I know that I need a UI, I have some screens on like some forms that are going to be submitted. I know I need some APIs to talk to the front end, the mobile app, and the back end, and then I have my back end changes. We don't want to think about MVP as each of those individual components because they each individually have no value. So really, it's about slicing vertically, so that way we can get something built. If it's a mobile app, being able to have some screen, some functionality in the mobile app, getting some core APIs built and the back-end functionality. So that way we put something in the customer's hands, they can start to do some type of transaction, some types of processes, and we can learn and then iterate based on those processes. And then also, you know, what's the construct that we're following for Agile? In a large enterprise where we have many teams working on a suite of applications, suite of products, it's really important that I think of like the scaled Agile framework or SAFe. I really do like this framework, but it does get a bad rap because people use it in a waterfall setting. They use a release planning event to basically come up with all of those requirements, and then they leave their teams go for 3 months. And that's really not the point of Agile or even MVP. So we want to be able to do some level of planning, but we need to be taking information from production and iterating and evolving our teams as we work in sprints. And this is really key. Trunk-based development. So as part of writing clean code and being able to get to continuous delivery, we really need to have one path to production, and we need to be able to force integration from each of the developers early in the process. I have been at companies where each team had their own branch. And then like what happens is, okay, well then each team has their branch, it lasts for a sprint, but then when all of it comes together, it all breaks, it's all crap. And now we're spending time figuring out what all those integration issues are. And some people say, well, you know, trunk-based development, man, it's really painful because I got to talk and coordinate, and you really have to make sure you're not stepping on everybody. Yeah, that's the point. We need to be communicating. You need to force this issue, because otherwise, when you don't, and you're not talking, and you're letting people make commits that aren't coordinated, ultimately it's going to crashing down. So you either pay for it now or you pay for it later. And that's really, when you think about Toyota and quality management, they have the and-on cord where you can stop the production line at any point. And part of, you know, this concept of trunk-based development is that we're able to understand what's not working, you know, as soon as it happens. And we know that the cost of fixing that issue, those commit conflicts, that fixing those issues earlier in the process is going to be much faster and cheaper than doing it later on. And then taking that one step further, we absolutely need to have a continuous delivery pipeline. We need to have a set of tasks that are automated, that the developer is able to run, so they can build their code, they can run all of their checks, the security scans, the unit tests, stubbed out integration tests. They can run all of those things, and then based on the success, they have a pull request that's able to merge that into the trunk, and then you have your next set of activities that kind of build on itself, gets deployed to a test environment, the next set of tests run, etc. So this is key. This is the backbone of our environment, our engineering factory, if you will. And all of the work that we're doing, all of these tasks that we're doing from build and deployment and test, figure eight, all of those things are automated and they're part of this process. And that's critical. I mentioned infrastructure as code already. So everything really needs to be treated as code. So whether it's infrastructure or tests, all of that should be in source control, all of it should be versioned. And this is the pivot that our infrastructure team needs to make, you know, rather than, you know, just manually creating environments or networks, being able to write scripts, you know, using Chef or Puppet or other tools to be able to automate the infrastructure process. And that way the teams are able to reuse that and customize it. It's all under source control, and therefore it's well controlled and maintained. And that's a key capability for engineering excellence. Again, from an Agile perspective, being able to have cross-functional teams, so moving from project-based teams or application teams to product teams. So a product team, if the product is a mobile app and that mobile app has APIs, maybe has like a Salesforce backend, that team needs to have all of those capabilities on that team so that they can deliver features. That's a very important pivot that we're seeing much more prevalent today in these high-performing teams versus an API team and a mobile team and a backend team, and then they have to work through integration, and ultimately they have issues, and they're still not understanding exactly what's the value of what they're building and how the client is going to take advantage of it. So cross-functional teams, moving from project to product, it's critical in an engineering excellence environment. I kind of talked a little bit about this, and shift left is a buzzword that's been around for a long time now, but it's really critical. It's being able to tell the developers that something doesn't work as soon as possible. So being able in that continuous delivery pipeline to have the quality checks baked in, to be able to automate in real time. So when we talk about shift left, it's, I talked to a client yesterday who said, well, we have engineers on our team and we have manual testers on the teams, and then we have a separate group who does automation. Well, the problem with that is that, the manual team is only going to test some things, probably the features that were just developed, and that takes them time. And then the automation team is going to do something else. And so you're going to be finding defects later in the process, and those developers have moved on. And we know, again, that the time it will take for them to switch back, that context switching, being able to switch back, understand what they had built and then to fix it, there's a higher likelihood that they're going to break something else, as well as the fact that it's going to take them longer to fix that issue. So shift left is really about getting automation built as soon as possible. It also means that our testers are evolving. Our testers are becoming more like engineers. Now, I'm still of the belief that we need testers on teams, but those testers should have an engineering background. They should look like developers. They should be able to understand the architecture. They should be able to understand CI and being able to take advantage of cloud environments, but they need to have a testing mindset. We absolutely have clients who have gotten away from testers, and then they just have engineers who switch each sprint between testing and development. And that definitely can work, especially on a small scale. But once you start to get into more complex products and teams do have to do some level of communicating, it's usually when you need to have someone who has a testing mindset to be able to implement something like BDD or other integrated types of testing. So being able to shift left, get testing early and often into the process, evolving the testers so that they are engineers as part of the process, and testing is part of the definition of done. It's critical in engineering excellence environment. And then just taking that a step further. So these are some of the typical quality gates that we would expect to see in a full continuous deployment, continuous delivery environment. So being able to have the code scans, being able to have, so this is basically every step of the way from the developers and their feature branch to then when things get merged into the master branch, and then when you start to deploy it. So continuous testing is a common buzzword in the industry. Many people think that continuous testing is just having automated testing, and clearly it's not. Continuous testing is having all of the tests that are required to certify a feature. They're all automated, they're integrated into the CI process, and they don't allow the code to move beyond that quality gate unless those critical thresholds have been met. And this is really the ultimate maturity when we talk about engineering excellence. So how do you know where you are? so you're an engineer, you're part of a team, you know, everything I said makes sense, you get it, but you want to understand like, okay, well, how is my team performing? How do you get started? So the first thing is understanding like these critical errors. And so the first one is around the operating model. And as I mentioned, moving from project to product, being able to have Agile and DevOps methodologies in place, and that team has that full autonomy to build, to own what they build. The second is from an engineering culture, being able to invest in your people, having time for innovation, having time for them to learn about clean code, to learn about new capabilities that your cloud provider is rolling out. And then the third is having that reusable platform that teams can quickly take advantage of, whether it's CI or testing or infrastructure. So that way they're able to quickly get to a high level of maturity in engineering excellence versus having to build everything themselves. And this whole thing is based off of flow. So we want to be able to maximize our flow to production. And so when we talk about the metrics, there are 5 key metrics that have been proven. These come from DORA, DevOps Research and Assessment. It started in the State of DevOps reports from Puppet Labs many years ago, and then DORA was a company founded by Nicole Forsgren, Jez Humble, and Gene Kim, and others, where they started to really deeply understand the results of the DevOps survey that was coming out from Puppet Labs. And what they found was these 5 metrics have a direct correlation to IT performance and ultimately engineering excellence. And so lead time, so the time it takes for a commit to get all the way through to production, how often that's happening is deployment frequency, how often those deployments fail, that change fail rate, how long does it take you, the mean time to restore, how long does it take you to recover from a failure, and then the availability of your system. And so these 5 metrics are key to being able to understand how your teams are performing. So the first question is, do you have these metrics? Many times we don't have these metrics. We do something called an engineering excellence assessment, and part of that work is to baseline these metrics for applications. And this takes significant manual effort because these metrics aren't readily available. A lot of times you can, through brute force, you can force the issue. You can say, well, like, let's throw more people on it so that we can, we can get product out the door every sprint. But then there's usually a side effect. Usually by forcing the issue without automation, you're going to get a high failure rate on those issues. And so this is really good to be able to understand how you're performing and to focus in on where you have opportunities. And as part of the DevOps reporting that's come out by Google and DORA, there is a key performance metric that those companies that have exceeded in these metrics of lead time and mean time to restore and change failure rate, et cetera, like they clearly are elite performers based on how their company is doing within the market. And so that's why this is very important to understand, where are you? Are you a medium performer? Are you a high performer? Because that's going to help you understand where you're going to need to invest. And just some, going down one more layer here, these are some of the baselines of what we see. So an elite performer is able to get, new features to production, within a day. High IT performers are maybe a week, medium is maybe every sprint, every month, and so forth. And so these are some just like high level baselines so that you can see, where does our team fall in this process. But this is really important starting point, because a lot of times we can't just do things on our own. We need to go to management to make the case for making an investment. And understanding these metrics and then the potential for improvement in these metrics is going to have real value to your business. If I can go from a new feature release from every 6 months to every month, well, that's huge. I go from 2 releases a year to 12 releases a year. That's more features. That's more interaction with our clients. Now, sometimes when I say that, people who work maybe for a SaaS company, they say, well, our customers, they can't really handle a new release every quarter. And that's fine. As part of engineering excellence, what we see is that there's a decoupling of release and deployments. So when we talk about deployment frequencies, we can put stuff into production early and often, and we just don't have it available to the client. But what that allows us to do is we can do some canary testing, we can do some production testing in controlled environments and make sure everything's working. So that way, when we do a release is a configuration change. A release is turning it on for different customers. It doesn't require an outage. It doesn't require a huge event to happen. And we know that by decoupling deployments and releases and being able to deploy early and often into production with small changes, the quality of those changes becomes much higher. And all of this has real value. And so when you want an investment to your team to help fix your CI process or to invest in learning how to do clean code, understanding these metrics is how you're going to make the case for what your leadership and your business is going to get from making this investment. So let's talk about how to get started. So we have the metrics. You have a high level understanding of, okay, this is our lead time. This is how long it's taking us to get things out the door. But like, what's really making that up? And so the first step is doing something called value stream analysis. So this is sitting down with your team. Obviously, you're not, maybe you're not in the office. So Miro boards has become a really powerful tool that allows you to do virtual sticky notes and great collaboration. So get everybody into a common Miro board and ask them, okay, let's walk through the process. We get a story. What happens? What meetings do we have? Where does that story go? What's manual? What's automated? What has value? What doesn't? How long does all of this take? And just put it all down. And what this allows you to see then is, where is that lead time being spent? Is it being spent on manual tasks and working? Is it being spent on automation? Do we not have access that we need? The process of doing this is going to shake out all types of issues for the team to focus on building more automation. Maybe there's an organizational issue that there's another team that's doing the build and deployments, and they have a ticket process. So as part of our DevOps initiative, like, they need to give us the capability to do that. Maybe there's a UAT phase that takes 2 months. And so how do we get that phase eliminated and built into our Agile practices? But doing value stream analysis is going to allow you to create an improvement backlog that will help you improve your the flow to production. It will help you remove some of the waste, and it's going to call out some organizational issues that leadership is going to have to help you solve. But values, after you have the metrics and you understand where your opportunities are, value stream analysis is now how you get more into the details to be able to build out a backlog. And really you focus on value and effort. So with that backlog, you want it to prioritize based off the things that are going to be the easiest to solve, but have the highest value to the team in terms of time. As part of that value stream analysis, we absolutely want to look at our CI process. We want to understand, what are all those activities that happen in our branches, in our pull requests, and as code moves from environment to environment, because that's also going to help us understand, do we have the right testing framework in place? Do we have the right approach to testing? Do we have the right testers? Do we have the right branching strategy? Are we writing code clean enough to work through this process? Do we have the tools that we need to be? This is going to drive our overarching continuous improvement pipeline. And so we need to take that value stream analysis and look at how our deployment cycle is working, because this is potentially going to need an area of investment. And again, it's going to directly impact the way that the team is working. Organizational design is a sticky one. Every time you go through the value stream analysis, you are going to identify issues with how your company works that you're not going to be able to solve by yourself. And so it's really important that, you know, as you go through this process, that you have some leadership support, somebody who has the CIO's ear, that can really be an advocate for you. I've been at previous companies where, you know, we rewarded people for project time and being a project hero. So when you ask somebody to make an investment in containerization, they would say to you, what project am I logging my time to? And there was no reward system in place to reward people for innovation or research and development, frankly. And that's something that I wasn't going to be able to solve for. That's something that I had to go to the CIO and say, listen, we need to change the way we do end of year recognition. We need to get rid of this project system. And that's a big task. You know, I mentioned before the shared services and being able to move away from, you know, shared teams doing work on behalf of the teams. So there's a whole organizational change management aspect to this where people need to be bought in. There's a lot of fear that their jobs are going to go away because of changing responsibilities. And so this, you know, the sooner you go through that value stream analysis, the sooner you're able to pick up these pain points, the better off you'll be, because you're going to need to get in front of leadership, and you're going to need to socialize these issues and frankly get an initiative within the company to start knocking them down. But organizational design, can be a huge issue with, you know, you might be able to do clean code, you might have good automation practices, but if you have a separate team that manages environments and there is a backlog for them to get on their board, like, you are not going to be delivering quickly and often. If you have no insights to production and you no idea how the quality is, like, you know, you're not going to be able to impact that. Rework is another good, so the value stream analysis, that's going to help you get an understanding of your backlog, you know, being able to understand organization design, like, so there's big boulders across the organization. But rework analysis is an interesting one, because what that is going to help you do is, you know, rework analysis is looking at your backlog and understanding how much time are we spending on new feature development versus defects versus other tasks, because management loves the concept of productivity and being able to improve productivity. And so if you can make an argument that making an investment in CI or some of these toolings or the education aspect, and there's a potential productivity improvement with the team, there might not be anything more powerful than that. And so it's really important that we're able to look at the productivity of our team, where our time is spent, because that's also going to help us understand how to prioritize the backlog of improvements, as well as put a business case together for leadership so that they understand what's in it for them. Because all of these things, everything I've talked about, testing, quality gates, and clean code, and CI, and all of that takes an investment if you don't have it in place today. And that investment could be slowing the team down. It could mean that we need to add additional resources for some period to get those capabilities. And no one is going to make an investment in those activities unless it's clear to them what the return on that investment is going to be. And productivity is a great way. Obviously, the improvement in lead time is one measure, but this is the other really important measure when it comes to putting a business case together on how to enable engineering excellence for your team, and what that is going to mean in real, you know, business terms. And finally, it's really important to just start on pilots. If you don't have, if you're not doing branching trunk-based development today, maybe you start with some of your APIs, maybe you have a new API initiative, maybe you start there and just, iterate, do some pilots, and then from that you can expand it. The value stream analysis, you can start with one team, and then based on the success of that team, you can roll it out to other teams. Same thing for testing. Let's say you're a Java shop, you take one Java team, put in a new automation framework, integrate it into the CI process, and then ask your shared service team to help roll that out to other Java teams. So, find things that you can do within your team to show value, to show in real terms for your company, for your line of business, how they work, and then move from there. When before I joined EPAM, I was at a company called Capital One in America, and this process of taking one team, doing some of these best practices around engineering excellence, taking it to leadership, showing leadership the value it created for our team, and then asking permission to do pilots in other lines of business, then being able to come back on a periodic basis to show the progress of those pilots, and then getting leadership to say, what, like, we need to do this across the board. That really helped us drive engineering excellence at scale very quickly at a large enterprise, across maybe 1,000 teams, because of that capability. It's really, you could take the slide, you can let people listen to this presentation, but they'll still say, well, my stuff is different, our line of business is different, our applications are different. And so you have to go through the value stream analysis. You have to put those metrics together and put that business case together, because they're not going to, they're not going to believe you until you do that for them so they can see it in their terms. And then being able to do these types of pilots and experiments within their space, it's just a powerful tool in getting leadership support for the investment that it needs to put all of this stuff in place. Okay, I think that's it for me for helping understand that in this VUCA environment, why engineering excellence is so important and what engineering excellence really means and how to get there for your teams. So I'll pause here and see if we have any questions.
Yes, Adam, we have a few questions. Thank you very much. That was a great presentation. So we do have questions. Can you see the questions? Would you like me to read them for you?
If you could read them, please, because I don't have the screen up.
Okay. All right. Right now we have 3 questions. So the first one, what can you advise for correcting processes on the project where specifications are written right before development? There are lots of changes in requirements and designs. Of course, responsibility and understanding of features are concentrated in hands of particular people, and development velocity depends on these people more and more as the team sometimes is rotating.
Yeah, so it's really important in an engineering excellence environment that you have enough of a backlog or runway for the teams to work. So you really have to be able to highlight what bad is happening. And this is where some of that value stream analysis goes to show, are you waiting? Do you have developers that are losing time because they're waiting for those stories to be written? Also that rework analysis. So being able to see, like, is there a productivity impact because there isn't shovel-ready work for the team to be done? That's what you have to be, or maybe there's just like a lost opportunity for the team because, so you really have to find what bad is happening to be able to go back to leadership to say, listen, we need more time on backlog refinement. Maybe we need an investment in additional people to building the backlog, but you have to be able to articulate what bad is happening. And so that's the activity that you need to go find is how is it impacting the team? Is the team losing time and thus there's a productivity hit? Do you have, maybe it's not lost time, but it's non-productive time because there's a lot of churn. Once you get something, you have to really figure out what it means. Maybe you have to do a spike. And so the time spent on real development is far less. So you need to find that issue and then use that as as your hammer to say, listen, we need to make a change. Good question.
Thank you, Adam. So we have time for only one more question. So we will answer the questions, the other questions later. So the second question is by Joe. What is the opinion on developers writing not just unit tests, but automated acceptance tests and running them locally, and having testers add more scenarios to the test that the devs build?
So the short answer is that's absolutely fine. The team owns quality. At the end of the day, we need a team of engineers, whether they're developers or testers. It's a team of engineers. Everybody's responsible for testing. If the developers are the people who create the tests, and then you have testers who are able to take them and run them and do more with them, that's perfectly fine. In fact, it's a very common way for teams that are moving towards automation, where they don't have a lot of automated testers. They'll use the developers to do the first pass of the automation. It also helps the developers understand how to write better testable code, more automatable code, and have more accountability to what is being tested. So it's actually, it's a perfectly acceptable process. So thank you.
Thank you very much, Adam. So we're running out of time. Thank you everybody for attending, and we invite you to watch the next session, which is Expecting Professionalism by Uncle Bob. Thank you so much, and we will see you in the next session.